Today's topic is influence coefficient method, and under the influence coefficient method we are going to see the flexibility influence coefficient. Now what is mean by flexibility? So flexibility is the reciprocal of stiffness. So flexibility is reciprocal of stiffness. That means the flexibility matrix is represented by A. So A is 1 upon K matrix. That means if we know that stiffness is force upon displacement, then flexibility is displacement upon force. So flexibility is defined as it is displacement upon force. It is just a reciprocal of the stiffness, and this flexibility is used for finding for analyzing the multi-degree of freedom system. So we have derived the equation of motion by using Newton's second law of motion. Okay, but by applying the flexibility influence coefficient method also you can analyze the multi-degree of freedom. That means you can find out the eigenvalues and eigenvectors of multi-degree of freedom system. How? That we are going to see in today's lecture. Now we know that the equation of motion of multi-degree freedom system will be M matrix into K double dot plus K matrix into X is equal to 0. So this is for undamped free vibrations. Now we know that A matrix is reciprocal of stiffness. So it is A matrix is K inverse. Okay. Similarly, K is equal to A inverse. Okay. So K is equal to A inverse and A is equal to K inverse. Now here, say this is equation number 1. So we multiply equation 1 with A inverse. So equation 1 becomes, so this is A inverse multiplied by M into X double dot plus A inverse into K into X is equal to 0. Okay. Now so here instead of multiplying it is K inverse. K inverse, so this is K inverse. Now we know that K inverse is what? K inverse is nothing but A matrix. So A into M into X double dot plus this is K inverse into K is identity matrix into X equal to 0. And this identity matrix into X will be the X matrix only. So this will be A M X double dot plus X is equal to 0. So in this way we have converted the equation of motion into in terms of flexibility matrix. Okay, so where A is the flexibility matrix. Flexibility matrix. Okay, and its size will be n by n, where n is the number of degrees of freedom. Now this A matrix will look, it will be A11, A12 up to A1j to A1n. Similarly, this is A21, A22 up to A2j up to A2n. So this is up to AI1, AI2 up to AIJ up to AIN, and this is up to AN1, AN2 up to ANJ and ANN. Okay, so this is the influence coefficient of the flexibility matrix. Now what do you mean by this influence coefficient? Let us take an example of AIJ. So AIJ is what? So AIJ, we know that flexibility is displacement upon force. Now here we are considering force as unity. Okay, so flexibility coefficient. So flexibility coefficient AIJ, it will be displacement value. So here AIJ is displacement measured at ith coordinate when unit force applied at jth coordinate. Okay, so AIJ is displacement measured at ith coordinate when the unit force is applied at jth coordinate. Similarly, AJI is what? It is displacement measured at jth coordinate when unit force applied at ith coordinate. Okay, so these coefficients are basically the displacement values. Okay. Now we try to find out how this flexibility matrix can be obtained by taking one example. So I will take one example here. So here I will take one example. So this is mass 1, this is mass 2, this is K1, this is K2, this is displacement x1, and this is the displacement x2, and these masses are supported by roller support, and the friction between the surface with the rollers is neglected. So this is a 2 degrees of freedom system, and we know that and here we need to find flexibility matrix by using influence coefficient method. Influence coefficient method. Now we know that the flexibility matrix, this is 2 degrees of freedom system, so the size of the flexibility matrix will be 2 by 2, and it will look, it is A11, A12, A21 and A22. So this is a 2 by 2 matrix, and these are the coefficients, which are basically a displacement values. Okay. Now we take the first case. Now in first case we apply the unit force. So here we apply the unit force. This is basically unit force. So we apply a unit force here, and because of this unit force, the displacement is measured as K11. So we know that sorry, not K, it is A11. A11. So we know that A11. So A1 means the displacement measured at first coordinate, and the unit force is also applied at first coordinate. So this becomes A11. Similarly, the displacement at the second member will be A21. So A2 means we are measuring the displacement at second member, and we are applying the unit force at first member. Okay. And this is K1 and this is K2. Okay. So we will make the free body diagram. So here the first member. So here force is applied as unity 1. Now the displacement is happening in this direction, so this spring will try to apply the force in this direction, and its value will be stiffness into displacement. So this is K1 into A11. Similarly, this K2 multiply by displacement of this member minus displacement of this member, so A21 minus A11. Okay. Similarly, the second member, so here no external force is applied as in case of member 1. So in member 1 a unit force is applied, but in member 2 there is no external loading. So the only force which is acting is in this direction, so that is given by A21 minus A11. So the value is same, only the directions are opposite. Okay. Now we apply we will see. So here two forces are in this direction and one force is in this direction. Okay. So K1 A11, this will take as positive and these two are negative. So -1 minus K2 into A21 minus A11. is equal to 0. Okay. So this is, say, equation number 1. Now in the second here, so here only one force, that is K2 A21 minus A11 is equal to 0. Okay. And A21 minus A11 is equal to 0, and A21 is equal to A11. So this we have obtained. Now we will put this is equation number 2 and this is equation number 3. So we will put these values, put this value in equation 1. So if you put this value in equation 1, then K1 A11 minus 1 minus K2. Now if you put A11, so this becomes 0, so is equal to 0. That means A11 is equal to 1 upon K1. So this is the first value that we have obtained, and we know that A11 is A21, so A21 is equal to 1 upon K1. So out of the 4 we have obtained the 2 coefficients, that is A11 and A21. So these 2 coefficients have been obtained. Now we will see the second case. So in second case, we apply the unit force to the second member. So this is the unit force. This is the unit force. Now the displacement occur here will be A22, because we are measuring the displacement at 2 and we are applying the unit force at 2. So this is A22 and this becomes A12. Okay, so we are measuring the displacement at first member, but we are applying the unit force at second member. So this becomes A12 and this is K1 and this is K2. Now we'll make the free body diagram. So here in the first member there is no external load, only the spring force. So here since we are considering the displacement in this direction, so spring force K1 will be K1 into A12 and this force will be K2 minus, here we are considering A22 is more than A11, so this is A22 minus A11, and in the second member the same force will act but in opposite direction, and here there is a unit force 1. Now we apply the here, so this is K1 A11 is equal to K2 A22 minus A11. Okay, and the second one is K2 into A22 minus A11 is equal to 1, and this is A22 minus A11 is equal to 1 upon K2. Now if you put A22 as 1 plus, now here A22 is equal to 1 upon K2 plus A11. So put this value, say this is equation number 1 and this is equation number 2. So put this value in equation 1, then it is K1 A11 is equal to K2 in bracket, in place of A22, so this is 1 upon K2 plus A11 minus A11. So A11 get cancelled, so this get cancelled, so A11 is equal to 1 upon K1. Okay, so this we have already obtained, 1 upon K1. Now we will put, no, it should be A21, so it should be A21. Here it should be A21. This is A21. So A21 is equal to 1 upon K1. Okay, so this we have obtained. Now we'll put this A21 value here. So A22 is equal to 1 upon K2 plus A21 is this 1 upon K1. So this becomes K1 K2 K1 plus K2. So these are the 4 coefficients, A11, A21, this is A12, sorry, this is A12. So this is A12. Okay. So we have obtained A11, A21, A12 and A22. So the flexibility matrix, which is nothing but A11, A12, A21 and A22. So put the values here. A11 is what? 1 upon K1. A12 is what? A12 is 1 upon K1, and we know that the reciprocal values are always same, and through calculation also we have obtained the same value as A21 as 1 upon K1, and A22 is K1 plus K2 upon K1 K2. So this is how we have obtained the flexibility matrix by applying the influence coefficient method. Okay. So thank you very much. Thanks.